Welcome to the webinar with Firdaus Harun from Untitled Technologies and the ASQF. Thank you everybody for joining us today. Today the topic will be next level of static code analysis, anti-patterns and design issues. Firdaus Harun and I, Marcel Schwarzmeier from ASQF, will guide you through this presentation. Please feel free to ask questions by using the chat or the question function. We will be happy to answer your questions after the webinar. Now I'd like to hand over to our expert, Firdaus, and enjoy the presentation.
Yeah, thanks, moderator, for introducing a little bit about my topic and me as Firdaus Harun. So today I will talk about the next level of static code analysis, anti-pattern, and design issue. Is that all? So I think I will talk more about this static code analysis tool. So in this presentation, the main idea behind this talk is about state of the art this topic. I mean the static code analysis tool, and then we try to explore the generation of code static analysis tool from the very beginning until right now, and then we will try to look what could be we explore more on the static code analysis tool. Okay, so me, Firdaus Harun, I work as a client solution lead and software quality researcher at Untitled Technologies GmbH at Frankfurt. I work closely with clients on helping them improving their code quality, and at the same time, I work closely with engineers and developers how to improve their code detection and anti-pattern detection, and also verify and validate their algorithm. So I also interest with the software quality and technical depth topic. Okay, so as I said at the beginning, there will be three main topics. State-of-the-art static code analysis tool. I will talk about a little bit about the static analysis tool, maybe what could be effect or impact to the system if we ignore some of the code smell anti-pattern, and what could be the challenges for static code analysis tool. And then we will explore from the beginning how the static code analysis tool begins and until now, and then maybe we could try to discuss maybe some of the features that could be improved in the static code analysis tool. And if we have more time, I will try to discuss a little bit about the technical depth. Okay, so in this talk, I will not talk about static analysis in depth, of course, because this topic is quite big. Yeah, we can say anything about this topic, but I will not look into depth, and also I will not explain what are the all the anti-pattern and design issues that we have right now so far. Okay, so there are a lot of code static analysis tool out there in the market, but my talk in general try to explore what exactly static code analysis tool. Okay, so first of all, the state-of-the-art static code analysis. So what we know is about static code analysis is a tool that helps developers or managers to detect any weaknesses in the structure of the software, and it also can measure, calculate the metrics, any software metric that we want. Okay, so it means that we want to see how exactly our code look like, how our quality of the code, and we also want to see how the quality the code from a data perspective. So it means that some of the static analysis code static analysis tool have present the output in terms of the grade, in terms of the graph, or in terms of the trend line and graph, and etc. Okay, so the area of this we call the static code analysis. Okay, from the code base, and then we dump into the static code analysis tool, and then we see the result from the tool. So all this element or area called static code analysis. Okay, and then so where exactly we use this code static analysis tool? So we know that all enterprise or all companies really want to have a good product. So the good products come from the good code quality. Okay, so we start with the source code. Okay, so if we can imagine that we have more than 1 million line of code, and we try to analyze, try to measure its quality. So how? So there are many things, there are many different methods to do that, but in general, we have this kind of source code, or maybe we have a build script. I mean, if we try to analyze the source code in terms of continuous integration pipeline server, so we can dump this thing into the code static analysis area, I mean the tool itself. Okay, so and from there it will translate the source code into the abstract syntax tree, and then we try to compare if there are any structural weaknesses inside them. We try to also measure the structural properties inside the code, for example, like line of code, number of methods, number of packages, maybe complexity, and etc. Okay, and then they are stakeholder. I mean, the one who really interested with this kind of static code analysis. They are developers. So developers really interest with this code magic. I mean, when we have some issues, the developer will try to look what exactly the problem from part of the code. If we look into, let's say that the part of the code have complexity issue. So he really want to know how many complexity they are. I mean, how many loops or how many if else that really make the developer had to comprehend or to understand the code. And the other part, I mean, the one who really interests in on the top level layer are evaluators. It can be from the managers, it can be from the lead engineers and others. So these this guy really want to see what are the quality, what are the current quality inside the code. Is it give the A grade or B grade, or maybe it rank from 1 to 5. 1 is the bad one, 5 the best one. Is it score 5 and others? Okay, so from there it will give the nice output, the nice result. Okay, it depends how the static code analysis tool try to interpret from the data they get from the static analysis tool. So it can be present on the quality score, or it only present the metrics. Okay, or maybe it can visualize the structure of the properties based on the building blocks, for example, like city view, or maybe it could represent based on the structure dependency based on the I mean from the incoming or outgoing dependencies. And maybe if the stakeholders really interested with the issues, so we can present this code static analysis tool based on the issues. I mean, we can list all the issues and we can rank them based on the severity or based on the risk, and from there we can try to analyze maybe what are the most risky or most severe smelly class inside the application. So that's the general that we use code static analysis. Okay, and then okay, so after we have some ideas where we should use this kind of code static analysis tool, so of course we need to know why we need this static code analysis tool. The first one, of course, we want to ensure that the code base are confirmed with the high quality software design. I mean, there are a lot of software quality models. There are a lot of code quality principle out there, but of course, we need to find one that really reasonable, really important to the organization or company. It depends. So we can say that open close principle is the best one. If we really want to have focus on the modularity, yeah. So open close principle in a brief is we try to open for we try to make this class open for modification and close. Open for extension but closed for modification. So that's the idea behind the open close principle. And then the next principle could be the single responsibilities. So I think there are people out there are really know about this principle. So single responsibility is a principle that really to have one single task for one class or one set of tasks that really common in interest. Okay, so if we have a single task or single responsibility in one class, it means that we really focus on that task. We don't have several tasks that are different from each other, because at the end we want to have easy and maintainable software. And then we also can follow a set of design patterns. There are a lot of design patterns from the Gang of Four. Yeah, we can follow them if they are really suit with your vision or architecture. Okay, and the next thing why we need, of course, at the end of the day, we want to have a high quality product to make the customer happy, because this is value for them. Okay, so because of what? Because from this good quality, it may lead to the less bugs and defects. That's most important. Okay, when we develop the software, we try to analyze the code quality of the software, and then we are convinced with the result of this code quality from the code static analysis tool that they are ready to be shipped into the client. Okay, and then the last one, from this code quality, we can have a maintainable software, and at the end, we also have a very less minimal to refactor and fix the software. Okay, so from my experience and my survey on the literature out there, so there are very bad or very negative impact if we try to ignore all the issues and code smells if we have in the code static analysis tool. Okay, so yeah, in a brief, so if we have a code class or brain method in our software, okay. Okay, before that, I will try to explain a little bit about code class and brain method. So code class or brain method is a class or method that have more than one responsibility. I mean, it want to do a lot, more than one. And also this class or this method have a lot of complexities, which is a lot of things you want to do and a lot of logic inside that. So which is really big and really complex piece of software. So there are few research that really see what are the effects if we try to let the code class or brand method inside our software. The first one is flaw design in architectural design. In architectural perspective, code class is the most flaw because it will it will jeopardize your software if we try to fix this code class, because it will depend on all the classes out there, and if we fix this method or this class, it will give more butterfly effect to other. And the second effect or impact with code class is it will conflict the code merge of the codes. I mean, yeah, if we fix the God class, and there will be conflict when we try to merge the codes. Okay, so what could happen from this merge conflict? It will lead to more bugging. I mean, a lot of number of bugs will contribute after that. Okay, and the last one, the God class or brand method has a positive correlation with the defects. It has been researched by Zasworka and with his colleague. So in this paper, he tried to explore what are the relationship between the code class and the defect that output from the software. So when he and his colleague tried to measure using a statistical method, it said that there are really positive correlation between code class and the number of defects that produce from the software. Okay, and the second code smell called data class. So data class is a dumb holder. I mean the class that hold the data, which consists of getters and setters methods. So it did not doing anything, just hold the data. I mean that it really violates the principle of object-oriented. Okay, so what could be the impact if we ignore this data class? It will make the editing effort will take much more longer than the usual one, and also this data class actually have too many dependency with other classes. And then the next code smell called feature envy. Feature envy is a class that really have many dependency with other classes. It means that the method that hold the method inside this class or this feature envy class really interest with other classes. I mean other methods. So that's why we call it feature envy. So so what the impact? The impact is if you want to search this kind of class, it's very hard because there are a lot of tangling or complexity inside the class, and also at the same time, from the tester perspective, it's really hard to implement the unit tests. Okay, and the next smells we call a shotgun surgery. Okay, so inside this smell actually have a method that have incoming dependency from outside the classes. Okay, so why it called shotgun surgery? Because if we fix this method which has incoming dependencies, it will also give a battle effect to other outside the classes. So that's why it called a shotgun surgery. So what could be the impact of this shotgun surgery? It will have a lot of duplicate codes inside it, and also it takes more time to develop a small feature because the functionalities are splitted into several classes. So it is hard to fix in this class. And also from the developer perspective, it's really hard to comprehend what exactly that this class really want to do. Okay, and the next message change. So message change is one of the code smell or anti-pattern inside the code level or architecture level. So from my experience, when I try to analyze several open source projects, so I see that message change is one of the frequent smell located in the software application right now, because because of the method really want to call this method or this class, this method really want to call this object, and it really have a continuous calling, okay, from A to maybe to C or to D, and it really have a transitive dependency. So it means that this class is really hard to fix and also to maintain. And the second impact for the message change smell, it really give easily fragile, okay, because this dependency between classes or objects are dependent each other. If we try to fix in the middle of the change, I mean the middle of the continuous dependencies, it will really break. Okay, it means that it's really break the continuous dependency between the color and the quality of classes and methods. Okay, so there are many more actually, but I'm looking for these 5 which I compile and try to survey from the literature. Okay, so the next one, we are talking about the state of the art. Okay, so what exactly the current trend of static code analysis tool? So I survey a lot of static code analysis tool, and I try to generalize into 7 most common feature. The first one is the current trend. I mean, the state of the art code static analysis tool have this code issue smell anti-pattern detection. There are a lot. So they have a good rules, and they have a lot of detection rules. So from there, we can detect this kind of code smell or anti-pattern issues. And also, this is common. We can measure the structure property of the software by using certain code metrics. And also, some of the tools have this kind of code quality model, which is maybe based from the ISO 25010, or maybe from part of the ISO, for example, like maintainability properties. Okay, and there are lots. Okay, and some of the tools also have this kind of style code guideline. I mean code style guideline. So if you work in some companies, so these companies also maybe have some own rules on their code style. So you have to follow that in order to make it more understandable and more maintainable. Okay, and then we have the views that really help developers or managers to understand the structure of the code based on the dependency view or the city view. And we also have duplicated view. I mean, some of the code static analysis to really help developers to detect which part of the code are really duplicated or not. Okay, and the last one would be the dashboard. I mean, this is the main user interface for manager or developer to understand in general what are the current quality of the code. And the last one would be the aggregated metric. So aggregated metric means it will aggregate all the metric or several metrics in order to have one score or one index. For example, like technical depth index, or for example, like quality score, something like that. Okay, so now this is the trend in the current static code analysis. So there are a few challenges that happen that face for static code analysis tool provider. Okay, one is if we have large scale application, so maybe some of the information are lost. Okay, because now the technologies come into the microservice, cloud, everything. So it's really hard to analyze everything into one piece. Okay, and the other thing is it's really hard to predict the bugs. So for example, like if the part of the code really produce a bugs, so but if we try to fix this part of the code, is it really make the code bug in the future or not? So this is something that we miss, or this is a huge challenge that faced by the code, static code analysis to provider. And the second one would be false positive. Okay, so there are a lot of issues. There may be an endless list of the code issues or code smelly class, but which one are really true positive classes? So that's always the huge challenge for the code static analysis tool provider. And also the threshold itself. So because we have a bigger application, we have the small application, to define the appropriate threshold really hard. I mean, yeah, it depends on the size of the system. And the last one would be more on technical view. Still seem there are the lack of IDE, DevOps, IAC integration. Yeah, I know that there are few code static analysis tools have provide this kind of integration, but still it does not really convince developer that really have in their development workflows. Yeah. Okay. So there's still three huge challenge still happen or still need to be considered to be improved for static code analysis tool. So there are lots, but I think these three are really interest for me to just to present to you. And if you talk about how can we interpret the result or the output from the tool, also a huge challenge for the static analysis tool provider, because it can interpret whatever we want, but what exactly we want to try to understand from the code. And then if we have a lot of data, I mean, if we translate the code into the element after the after we analyze the code, we can have a lot of data inside it. I mean, the producer of code static analysis will also have a huge problem to organizing or to how to lay out this information to the developer or to the manager. Okay, so this is the challenge that really faced by the provider. So so there are some mistake. I mean, when I try to go to the clients and then try to understand from the research paper, there are few mistakes that people or developers use the code static analysis tool. The first one is they are just really focused on the metric. Okay, so because the number is there, okay, they're really interested with the matrix value, but somehow it does not reflect with the architecture at all. Because of what? Because of if you want to go to more agile, go to more make the architecture more evolvability. I mean, we need to really have a good understanding thoroughly, and we need to have do in-depth analysis on that. Okay, and the next one, what are the mistakes that current developers use the static code analysis tool? I mean, they are really focused on the metric and the metric as a target goal. For example, like we want to have a grade A for this application. Okay, so now we are in the B score. We want to go to the A. So what we do, we try to do whatever we want without thinking in depth what exactly we want to go. I mean, in our vision, in our architecture. So the developer, we try to they are doing their hack way, I mean the shortcut way to improve the quality, to improve the metrics value. Okay, and at the end maybe the codes or the developer that fixed the code really doesn't meet the requirement what the architecture want. I mean, the code base doesn't reflect with the architecture at all. Okay, so that's the current mistake that we actually do with the with the static code analysis tool. Okay, so we go to the okay, we have okay, I can try to make a very quick view with the generation of static code analysis. So I have tried to compile all the static code analysis tool and try to understand the literature. Okay, there are first generation which is focused on the lean tool. I mean, we go to the syntax or format of the code. We try to detect all these issues, and we try to refactor on this level. So I mean that they have a very limited capabilities and very minor metric that capable at that time. And the second generation, it's going beyond more easy to use. I mean, they are more intuitive and more enriched information based on the UI. So at the same time, it also detects a lot of code smell. It also can catch bug. And at the same time, we can also prioritize and rank the issues. Okay, and we also have some views how the file dependent between each other, and also have a lot of structural metric we can have, for example, like complexity, number of child class, debt inheritance, etc. Okay, and then the third generation, so we have a lot of more features, so which I concern on in this generation. I mean, the code static analysis tool support most type of the languages, from the TypeScript, from the scripting languages, object-oriented, or whatever language so far. So of course there are a few things can be improved, but at the moment we are trying to give some useful feature for developer to use the code static analysis tool. And also some of them now looking to more aggregated metric, which I think useful also for business decision or based on the technical depth perspective. Okay, and then for the next, maybe much more nice is to have what's next. I mean, maybe we can adopt some AI or machine learning in our code static analysis tool, and then we can give more useful to developer or manager to convince them that code static analysis tool are useful for them and really help them in the development workflow. Okay, so what's next? Okay, so we still continue, moderator?
Yes, you can continue.
Okay, so what's next? So maybe I will present maybe two them, which I think really looking forward to have this kind of feature in the next generation of code static analysis tool. Okay, so the first one is automated refactoring. I mean that this is a lot of tedious tasks. I mean, if we find the bugs or the smelly code in our software, the first thing first is how should we refactor? Okay, and how many hours or man hours really we want to invest for this refactoring. So if we talk about refactoring, it can be in the code level, functional level, architecture level. So if we have automated refactoring, what are most important is to have this search-based optimization technique. Okay, so we try to find what are the next step of refactoring to have a minimal cost and a good quality in terms of metrics. Okay, so from this part we execute, and it also change the structure of the software without disrupting the behavior of the software. And at the last one, we can have a good or refactored code at the end. So I mean that that's not much take for refactoring efforts, but just looking how can we improve the refactoring technique to execute. And the last feature that I would say important to have is recommendation engine to recommend the developers or manager that which code are have a likelihood to be bugged, okay, in the future. Okay, so one thing that we can do is from this diagram, if we can see that every code that we commit actually have the code changes, of course, and also it's referred to some bug. If we use any issue tracking system like Jira or whatever, so we can see the correlation between that. And from this, actually, we try to extract from the historical data and try to match a new code with pattern which we previously learned. Okay, so our product Embol have this kind of recommendation engine. So we try to learn from previous pattern and try to give some recommendation which code or which part of the code have likelihood have a bug in the future. So we use a neural network with a long-term memory to train this data and gives some recommendation to the developers. So in the end, we will see what which part of the code could have a buggy code. I mean, may introduce another bug. Okay, so this is EMBOL. So as a quick overview, this is we have at the moment we have a quality score which really to understand from the main score 1.67. So this is the example. So we analyze one big application open source project called Hadoop, okay, in the version 3.1.1. So we try to analyze and use our product, and it's called 1.67. So it means that in our quality rank, the 5 is the best one, and -5 is the indicate the bad one, the best one. So it's actually the aggregated metric which derive from the design, from the metrics, duplication, and code issues. Okay, so at the same time in this UI we can see the summary of information, and to help the developer which issues should be refactored. We also list the hotspot which require the attention of the managers of developers. So this could be the first step to improve their code quality. Okay. So and the same time in this UI, we also try to prioritize the issues automatically, okay, based on the severity and the risky that may happen to the application. And this is nice view from the EMBOL. We try to visualize the properties of the code. I mean, in terms of size of the class, line of code, and the severity. I mean, the riskier of the code. So the bigger the square, I mean, the bigger in terms of the size line of code, and the darker the red, I mean, the more severe it is. Okay, so from this one we can filter which one have score below than 0 or below than -2. So from this we can tackle which class has more severity and also have a bigger size, okay, in terms of line of code. Okay, so of course there are few more features that could be considered. For example, like dynamic analysis. We can try to analyze in depth in terms of the behavior and also the memory usage of the application. We also can try to have security flaws detection. Okay, try to understand the context of the class and also maybe some misuse of the API. And also it would be nice to have if we can integrate this static code analysis tool into the DevOps server and also into the infrastructure as a code server as well. And as I said at the beginning, it would be nice to have AI, I mean self-learning anti-pattern detection. It will learn how the developer change the codes, and at the same time it try to detect what are the most changes or anti-pattern that happen in the software, and at the end it will try to give a recommendation that this class has need to be refactored or fixed. Okay, so yeah, at the end I would like to end my presentation with first is, so of course in order to ensure our code quality we need to have a tool called code static analysis tool. Of course this is not the silver bullet solution for all company, but this only can help us or give some insight what are the current quality of our codes. And then yeah, of course there are a few limitations in our in the current static code analysis tool. Of course we need also a human intervention. I mean an expert should be helped along with the code static analysis tool in order to reduce the false positive smelly classes. Okay, and from my research, there are a lot of ongoing research on this topic, on this domain. So directly or indirectly, actually, it influenced the development of static code analysis tool until now. And then I think that would be nice to have an AI, artificial intelligence, which combined with the static code analysis tool. It means that from this AI, we may have produce a better results, and at the end, we want the developer really use this code static analysis tool. So I think that's today for that's all for today. So yeah, if you have any question or you just want to connect with me, you can find me at LinkedIn and Twitter at Firdaus Harun. You can type my name there, and yeah, we can have discussion together. And yeah, hopefully we have a better and yeah, a better version of code static analysis in the future. Yeah, thanks.
Thank you very much, Firdaus. One question, can we have the slides later on for all the participants for of the presentation, so we can send it to them, PDF or something?
Yeah,
great.
I will for you.
Now we're open for questions, and I see there some question popping already in. The first is, in Firdaus' opinion, what are the best free board static code analysis tools?
I cannot see the question. Can you?
Okay, what are the best free or bought static code analysis tools?
The best and free?
Yeah, free or bought.
Okay, of course, I could be biased. Of course, our product MBOL are the best and free MBOL, the best product. So because we offer a varieties plan for individual developer, into the startup, into the small and a big company. Yeah, we have a full plan for them.
Okay. The next question is, what are the differences to the tools like Sonar Cube or Cast AIP, except the already mentioned automated refactoring and recommendation engine?
Can you read again the question?
What are the differences to the tool like Sonar Cube or Cast AIP? I don't know if I pronounce it right. Except to the already mentioned automated refactoring and recommendation engine.
Okay, I don't want to make obvious comparison between them, but what we have is, of course, the AI-based recommendation engine that we have right now so far, and then the second one, we also have a trend line. How to say, the trend line graph. I mean, if we have a lot of version of the software, we can see the trend of the software, how it's called for each version. Okay, so it will help developer or manager to see which software or which component are really I mean, increasing in terms of the quality or decrease in terms of the quality. And then, yeah, we also have a good rules. Okay, I mean, we have our R&D team that really invent on these things. Me, as a researcher also in this company, we really invest so much time try to find the current framework or the current trend in the program in the languages. For example, like JavaScript, or in the C or C++, we also try to comply with the MISRA C++ standard as well. Okay, and also we have these dependency views. Okay, so which we can see the incoming and outgoing dependencies. So not so much. I think we are the best one to have this kind of dependency. We can see all class that depend or call out the dependencies. So we have this so much new and wow features that really interest with developer and manager.
Okay, good. Thank you very much for the presentation and also for answering all the questions we had during this session. Yeah, good. Thank you very much and have a nice day.
Yeah, you too. Have a nice day. Thanks,
Bye.
everyone. Bye.